Then colon, is it possible to fail at city skylines? Find out. All right, cool. No, SpaceX. Like here. SpaceX. Like Xbox. All right. You know what the best thing about Xbox is? You know, the best thing about Xbox isn't actually beating the game, but showing everyone that I did. Show me your hands, chat. Show me your hands. Phil. Peregrine update number 846. Peregrine found life on Europa. We've managed to squeeze more life out of it. It is currently leaving the solar system. Boop, boop. You got an achievable. Yes. No hands. No, hey. All right, cool. This is the SpaceX talk. Let's do it. Let's do this. Oh, hello, South Park Elementary. How we doing? Konnichiwa, South Park. No? All right, cool.
All right.
Still sick.
It's been an incredible year. The SpaceX team, I think, is the best space team that has ever been assembled on the face of the Earth by far. And the achievements of the past year demonstrate that. I think to a degree that is mind-blowing.
So who's that guy? That's Mr. SpaceX. That's his name. His first name is Space, and his last name is X. It's German. It's spelled ECKX.
Like what you have achieved over the past year is nothing short of incredible. And one day we will indeed occupy Mars. So,
Bruh.
So let's go through everything that SpaceX has achieved that you've done, and it's actually going to take a while. By the way, this is going to take a minute. So first of all, with Falcon, we have achieved the most launches of any rocket in a single year ever.
I like this.
So the next best is was the Soviet Soyuz, which I think did a little over 60 launches in a year, and we did 96. So
get dunked on.
So no other family of orbital class rockets has launched more than 63 times a year. That was Soyuz, and we did 50% more. The Falcon Heavy also surpassed, in terms of heavy lift vehicles, the record for Saturn V, which I think did, I think we with 5 launches last year, we exceeded the Saturn V record. So that was like pretty incredible on Falcon Heavy. So this gives you a sense in pictures of how incredible that was. For a while there, I was like, I'd be posting something, is this like the launch that just happened or the one that is happening, or? Because there were like 3 launches that happened in the space of a few days.
Space. I get it.
But this is all the launches on one page. Oh. And so it's really, really incredible. All made it to orbit, all landed. So just a huge hand for the Falcon team. That was incredible.
Pretty good.
So.
I'm here.
2/3 of the missions were Starlink, but a third were for other customers, for NASA, for other communication satellites. It was a combination of Starlink plus a lot of other missions. So even if you just take the non-Starlink portion of the flights, that was more than any other vehicle last year by a long shot. We launched NASA's Psyche. ESA's Euclid, the X-37B spaceplane.
That was a good mission.
Multiple transporter missions. We did missions for OneWeb, Viasat. and we're actually on contract to launch Amazon's Kuiper constellation. And we treat everyone fairly, so you know.
Hi, Bess. Good morning.
Just one, and we managed to do 19 flights on a single Falcon 9 booster, which is really incredible.
RIP 1058.
In 3.5 years. And that vehicle that booster did 860 satellites and delivered 260 metric tons to orbit. So it's like, wow.
It's pretty good.
So there's a lot of wows.
It's pretty good. Wow.
And it's worth, you know, like how long ago was it that we landed a booster? It was actually 8 years ago, in December, roughly 8 years ago. And since that time, we've landed 260 times. So 260 landings. It's just like, wow.
Pretty good.
I mean, there were a lot of people that said that it couldn't be done. And then there were a lot of people that said, even if it could be done, it's a dumb idea. That it wouldn't pay off. That it wouldn't make sense. But we've shown that, in fact, it is absolutely the right idea. Reusability is the key to a great future in space. It's essential. We need reusability for rockets, just like we have reusability for cars, for airplanes, for bicycles, for horses. Obviously, reusability is essential. And the fundamental invention that is necessary for humanity to become a multi-planet species is a full and rapidly reusable, reliable rockets. So, like Space Pirate.
BC, start to launch auto sequence. Prop, confirm you're ready for engine chill in 30 seconds.
Prop is ready for engine chill. Spacecraft are on internal
This is a good day.
Stage 1 logs, Stage 1 fuel, Stage 2 fuel rates, all nominal.
All stations verify, ready for launch. All stations acknowledge. FTS.
FTS go.
Prop.
Prop go.
AVI.
AVI's go.
GNC.
GNC go.
OSM. Recovery.
Landings go. LCLD, go for launch.
T-minus 5, 4,
Yeah, probably, Boxy.
2, 1.
Why do you think I'm crappily singing over it? So it doesn't pick up on the VOD thing, you know? I remember feeling the opposite of falling. Spinning past the VOD muter so it doesn't get muted. Are you there or not? Hey, it works. As long as I talk over it, it's not going to detect it, you know? This is the best part, though. Right here, right here, right here.
Like a stage ignition. Stage 1 is under its foot.
Oh, it's because I'm good at what I do. Boom.
Stage 1 boost back is starting.
Yeah, that's the whole point. I was not far from that camera. I was there, dude. First landing at the Cape, man. I saw it. It was gnarly. Amazing. It's still good, man. It's still awesome, dude. It's still awesome. It's still cool. Bruh. Bruh.
Spacecraft 1 and 2 have been deployed.
Orbcom OG2.
Final Orbcom payload deployed.
That was pretty good.
Yeah.
Yeah.
So it's incredible how much has happened in 8 years. So, I wonder what will things be like 8 years from now?
Jeez.
And hopefully I think we will have landed on Mars. And I think we will have sent people to the moon. And maybe if we get lucky, we'll have sent people to Mars within 8 years. The key question, sort of, I think, about for civilization is, the key test, perhaps, for civilization is, do we make it through this Fermi great filter of going from a one-planet civilization to a multi-planet civilization? And if we do become a multi-planet civilization, we may go out there to other star systems and discover many long-dead one-planet civilizations. And we don't want to be one of them. That's lame. We don't want to be one of those lame one-planet civilizations.
Yep.
But I think we should always regard civilization as fragile, as not something that, not a situation where there is an inevitable upward trajectory. I read a lot about history, and if you read history, you see that civilizations are anything but permanent. That many civilizations have risen and fallen over the years, over the centuries and millennia.
I think about the Roman Empire, too, every day.
Eventually, the sun will expand, boil the oceans, and destroy all life on Earth. Now, admittedly, that's...
Do questions later, Cosmo.
Several hundred million years in the future, but...
Wait a minute. Do you guys not think about the Roman Empire every day? I think about the Roman Empire every day. You dream about it? Yeah. Word. Guys want to know a dream? I had a dream last night. That dream is that I had a SN95 Mustang, and I drove the Mustang to a bar, and the bar was blasting the Beastie Boys, so I wanted to blast the Beastie Boys in my dream, so I just turned up the stereo and blasted Beastie Boys with the bar. And the dream was me trying to sync the speakers. Yep. Then I woke up. Yeah. How's that? How's that for a dream? Yeah. Pretty good, right? Pretty good. Pretty good dream.
It's only about...
that's not the Roman Empire.
Or 20% of the existence of Earth itself. If Earth is 4.5 billion years old, then another 20%
maybe, John.
longer, and life would,
Maybe.
Or intelligent life would not have evolved, because it's taken us a long time to get to this point. So, that's really the key test. Do we become a self-sustaining multi-planet civilization while civilization still exists, or don't we? I think that's really the key question. I think we've got a good chance, but it's not a sure thing.
Oh, nice, Iger.
That's why time is of the essence. I think we want to make Mars self-sustaining as quickly as possible. It's not just a question of getting people to Mars, but it's getting enough tonnage and equipment to Mars to enable Mars to be self-sustaining. The key test being that if the resupply ships from Earth stop coming for any reason, does Mars die out, or does it continue? That's really the fundamental threshold to pass the Fermi paradox great filter. And the Fermi paradox is, where are the aliens? If life is common, if intelligent life is common, shouldn't we see a lot of evidence of it? Now, I get asked a lot about, aliens, actually. And I usually say I am one. Well, actually, I used to be, according to, Homeland Security. It's an alien registration card, literally. was like, okay. So,
All right.
but the truth is, I actually have not seen any evidence of aliens, which I think is maybe a bit more troubling than if I had. I have not seen any, and I'd be on it, and you can pretty much guarantee that I would post about it instantly. Okay.
On X exclusively.
I was like, yep, we got one. This is a spaceship for sure. But I have not seen anything. So
right.
that leads me to think that we're more likely to be a tiny candle of consciousness in a vast emptiness, a vast darkness. That the civilization that we have is really just this very, very small candle in a vast darkness, and we just must do everything possible to ensure that that candle does not go out. Yeah. Anyway, I think we can do it. So,
Hey, Bith. Tier 366.
but we need to move fast, because you just never know. I mean, there could be, at any given point, like Stephen Hawking actually, I believe, said that he thought there was like roughly a 1% chance in any given century of civilization ending. That was his rough estimate.
I love this
I think
graphic.
it actually might be higher than that. So we just want to go there fast. So this is getting back to Falcon 9, back to reality.
Snap back to reality.
This is,
there
these
goes
are all the launches
gravity.
we've done. And you can see how the cadence of launches has rapidly increased over time.
Yeah, it's pretty good.
I think people online have actually assembled videos showing every launch, and it just gets like crazy fast as you get to 2023. So we've done a 19.3 flight. We're now qualifying Falcon 9 to be able to do 40 flights, and we're aiming for maybe as much as 150 flights this year. So, and then let's not forget fairing recovery, because actually a lot of people don't realize we recover the fairing as well. This was actually very difficult to recover the fairing. So it costs an immense amount of effort. But we now quite regularly recover the fairing, and we've reflown fairings 300 times. So congrats to the fairing recovery team. That was actually pretty damn hard. So.
That's a starship behind him. 2 of them. On the right. Drone ship.
Oh, and then of course we do operate basically a small navy. I think people don't always know that, but we have drone ships and
Cool.
support ships of various kinds. So we've got a small fleet of ships.
Look at the person standing on it.
And we operate them very efficiently. I think people also sometimes don't know the size. Like you can see the size of the ship by the person walking around on it.
I just said that.
Not small. So it looks cool. I like this sort of kind of a Darth Vader aesthetic, but I like it.
Nodders.
So and we're also getting much better with pad turnaround. We achieved a 3-day pad turnaround, and I think we're aiming to hopefully, get under 24 hours pad turnaround by the end of this year.
Wow. I'd believe that. Yeah, that's
so
fair.
in terms of launch rate, so it's been 15 years since Flight 1 of Falcon 1. Oh, sorry, Flight 4 of Falcon 1, the first one to reach orbit. So 15 years since we got anything at all to orbit.
Look at the new boosters.
Yeah, and now we're aiming to have 150 flights or thereabouts this year.
That actually is
So-
pretty nuts. That actually is crazy.
And these are big rockets at this point. Falcon 1 is a little rocket. In fact, when I see Falcon 1 right now, I was like, man, I think I'd probably tuck that under my arm and just take it home with me. It was like launch it in the backyard or something. It
yeah.
looks so cute.
Hell yeah.
But at the time, Falcon 1 did seem like extremely. It was extremely difficult. It took us 4 flights to reach orbit, and it did seem kind of big at the time. But now it's like a adorable thing. So
Maybe he'll
yeah.
talk about that, Boxy.
So the most profound metric, or the metric that really describes the magnitude of what SpaceX achieved in 2023 is the mass to orbit number. So, and you can see the incredible change just year over year. So 2021, we're slightly below rest of world. 22, we, I think, roughly doubled what the rest of the world did. And
God, that's
last year, we were 80%
impressive.
of all mass to orbit.
wow.
So when rest of the world, we mean like the rest of U.S. industry, Europe, India, China, Japan, everyone. So there's not a lot of industries where a company is doing like 80% of everything. And then what's really mind-boggling is that number should increase by 50% this year. So I guess on the order of like 90% of all mass to orbit, not counting Starship. So if as we start launching Starship is like roughly 100 tons to orbit with every flight. There's a path to getting Starship to do over 200 tons with full reusability. So 200 tons to useful orbit with full reusability. And yeah, it's really an incredible amount.
That's
1,200
impressive.
tons of useful load to orbit last year. Yeah,
Okay.
that's just astounding.
Okay.
So I think that really deserves a round of applause. Like wow, I mean, it's just
Let's move it.
That's the
That's
most
like
mind-blowing.
moving an Abrams tank into space and then bringing it back down because, you know. All
and the
right.
rate of increase is just astonishing. Now, these numbers will actually look very small in the future. In order to build a city on Mars, we'll need to be kind of in the million-ton to orbit range. So maybe a little higher, ideally a little higher, but it's sort of, if you just try to get things to the right order of magnitude, like not trying to get to an exact number, but try to get the order of magnitude right. I think it's on the order. It's roughly 1 million tons to Earth orbit. That'll get you roughly 200,000 tons to the surface of Mars. So roughly, approximately 20% of what if you get to Earth orbit, you can get to the surface of Mars. And figure like maybe we need at least 1 million tons of useful load to the surface of Mars for it to become self-sustaining. That self-sustaining threshold is actually a very tough threshold to meet because even if you're missing a tiny thing, then eventually that Mars will die out. So you've got to be able to not just build, for example, computer chips, but you need to be able to build computer chip factories. Because if you can't build computer chip factories, the factory that you do build will eventually break down, and then you will have no chips. And then that's it.
And you'll be hungry.
So it's kind of like a long sea voyage where if you're just missing vitamin C, yeah, you'll cruise on for a while, but then, your teeth will fall out and you'll die. So
And
that was a real problem in the old days.
and 100% of the causes
Anyway,
of death
it's
is death.
quite a high threshold. And like Mars is a fixer-upper of a planet. Needs some work, but so it's not like you can just run around outdoors and fish or live off the land. You can't live off the land on Mars.
Very dangerous. Yep.
So it's really quite a lot of work that's required to make that work. So Dragon, an amazing amount of progress with Dragon, and an incredible track record of success. So by as of last year, the Dragon's fleet time on orbit exceeded the space shuttle fleet. So we had a cumulative over 1,300 days of time on orbit as of last year. So that's pretty mind-boggling that Dragon has now had more days in orbit than the entire space shuttle fleet. It's like, wow.
No.
So,
Man, don't hate on my
yeah.
space shuttle.
and we've had now Dragon has visited the space station more times than the space shuttle as well.
Nope. We're fact checking. No. Okay, he's right on that one. Dragon stays up on orbit. It can stay attached to the space station for longer periods of time. The shuttle wasn't designed to do that. It wasn't designed to loiter at the space station for long periods of time. So he's right. But don't you talk bad about my space shuttle, man. That thing is a masterpiece. It's a masterpiece.
This is an incredible achievement by the Dragon team. So once again,
We need Starship to do that, dude. Copium, shut your mouth.
As I was saying, this really has been an incredible. 2023 was like maybe the best year in the company's history. Yeah, I mean, it was the best year in the company's history, actually.
Dorothy
there's
Mantooth
lot of
was a
great things to
saint.
Go through. I'm not one who gives out false praise. So it's really mind-boggling what you've achieved. So all of the missions last year used a flight-proven Dragon. So
It's pretty cool.
these Dragons are all flown before, and this year we're looking to fly maybe 7 or 8 Dragon missions. So it's really been, fantastic success by the Dragon team.
This is a SpaceX hands-on meeting from today, yes.
This doesn't have audio. There's no sound in space.
Right.
Yeah, that's a great looking spacesuit. And in Dragon interior.
MLA right there. He's going to fly on the X3 mission in a a week?
So we've now sent 42 humans to orbit, to be precise. Space is relatively easy, but orbit is very difficult. So we've now taken 42 humans to orbit and back.
Oh, yeah.
And I have to say, like,
It's a good number.
yeah, if there's one thing I wish for, it is that we bring them all back safely.
Yeah.
That's like sometimes people like say, well, what is the one thing you wish for? I say, I wish we bring the astronauts back safely. That is one thing. If I had one wish, that's what it would be.
Fair.
So we also have now completed a second crew arm in Florida. So we've got 2 towers that are capable of 2 launch pads that are capable of sending astronauts to orbit. And this is going to be great for being able to shift missions between Pad 40 and Pad 39A.
Cool. Bro.
We've got this year our first spacewalk. So we've got to redesign the suit so that you can actually move around in it, and you don't just pop out like. Because if you just inflate the suit, you just basically, you're kind of like one of those balloons at a party or something, So it's quite hard to still be mobile in an inflated suit, and have the joints move and stuff, and then we will actually evacuate the whole spacecraft. So
Gemini style.
everyone, even those that don't go on the spacewalk, will still be in vacuum. So obviously very important that it work. We don't have like a little hole in the suit or something go flipping around. But I think obviously we're going to put a lot of testing into this, and but this is going to be another significant milestone, which is to have a suit where you can be in like the vacuum of space with just nothing at all, and just be out there. It's actually hard to conceive the concept of nothingness, and it's not technically nothing. Like there's a small number of particles per cubic meter, but it's pretty damn close to nothing.
What a nerd.
If you lose too much air, too much oxygen, that's it. There's no place to get oxygen from. So, like an airplane, even at high altitude, can increase the pressurization pumps and get more atmosphere because it's in the atmosphere. Dragon springs an oxygen leak, and that oxygen leak is too significant. There is no place to get oxygen. You're just going to die. So the requirements for getting everything perfect are insane. Everything's got to be absolutely perfect to work. We did not, evolve to live in space, obviously. So it's a tough one. But this is really going to be another great milestone, is to actually be able to have someone floating out there, in the vacuum of space, and come back. And we do want to actually have a spacesuit that you can walk around in, because if you're on the moon, you want to be able to walk around on the moon, walk around on Mars. So having a high mobility spacesuit that actually isn't crazy expensive, ideally, and that you can walk around in comfortably is a big deal. It's actually an important thing that needs to be developed, and ultimately made in large numbers. Because if we send, say, 1 million people to Mars, then that's 1 million spacesuits, or 1 million Mars suits that you need. So we'll have to make a lot of these things. And we're also going to launch Starlink on that flight.
Please mass produce
So they're coming to
spacesuits.
Starlink.
That's a good idea. We should do that.
This is normally a whole separate company, but we're basically rebuilding the internet in space, which is pretty wild.
Web 3.0.
Now,
in
it is,
space.
I want to emphasize, supplemental to the terrestrial internet. Sometimes people think, well, is Starlink just going to take over and destroy all the terrestrial internet?
No.
It definitely will not. But what it will do is Starlink will give access to the internet to people that either don't have access or where their access is extremely expensive or very, very bad access. So this is a massive enabler for enabling people in remote locations to learn anything. Like, you can basically learn almost anything for free on the internet right now. Like, for example, MIT has all of its lessons on YouTube. You can learn almost anything if you've got an internet connection. But if you don't have an internet connection, you're limited to, I guess, maybe you got some books or something. But
books.
Basically, Starlink is a game changer for improving people's quality of life around the world.
This happened today, Steam.
This
They
might
didn't
be the
do it
single.
live. Frick it.
Well, certainly one of the. I think it might be the number one over time technology that improves
bomber
people's
jacket,
standard
Joe.
of living around the world. It's certainly a candidate for potentially being the most profound thing that actually improves quality of life for people around the world, which would be really something to be proud of, obviously. So, let's see, and we're now introducing the V2 minis. So this is next generation satellites that we've introduced to the constellation.
That's not.
Yeah, these are
not a
twice
graphic.
the
That's a real
capacity
picture.
of last year, so from
So
88
cool.
terabits per second to 165. Our goal, the biggest single goal for Starlink from a technical standpoint is to get the mean latency below 20 milliseconds. So that actually makes it for immediacy of for actually the quality of internet experience. This is actually a really big deal. Also, if you play video games like I sometimes do, this is also important.
No freaking lag.
Otherwise, you lose.
100 tick, baby.
So this is anyway. So but that's actually a very, very hard problem. But because we're a low Earth orbit constellation, the speed of light is what do you think the speed of light is? 300 kilometers per millisecond. So if we're at 550 kilometers, think of it like roughly 2 milliseconds up, 2 milliseconds down. So if you go up, down, so 8 milliseconds speed of light limitation, and then almost everything else we can actually address. Like, we can't go faster than the speed of light yet, but probably ever. But we can get the rest of the time, I think, below 10 milliseconds, and so then it'll be more responsive than ground internet in most cases, which is really what we're after here. This is really amazing work. We also have now launched the Argon Hall thrusters,
Cool.
which are very low cost. And use argon, which is plentiful.
engines.
So we've gone from using krypton, which is not that rare. I mean, if Superman did come here, I'd be like, you can get some krypton, and squirt gun or something like that. And okay, now what? Krypton is a noble gas that is, it's moderately rare. But we would actually be using a huge percentage of the world's krypton if we were launching that with the Gen 2 satellites. And so we moved to argon. And argon is actually extremely plentiful. In fact, right now you are breathing approximately 1% argon. So argon there's a lot.
You think that's air
argon.
you're breathing now?
But this is really I think the first significant argon hole thruster.
That's
and
cool,
certainly by
man.
far the most cost efficient and the most power efficient. And it was a really great job by the Starlink team to create this thruster. And many other upgrades to the. Then there's the in-space laser
Sniffing that argon,
stuff. I mean,
baby.
so this is by far. I think we've now sent at least 1,000 times more data, maybe 10,000 times more data over laser links in space than any other system before. I think we'll soon be like
It's
a
true,
million
Jonathan.
times more data transferred, maybe more than that, through the Starlink laser interconnects between the satellites. So we now have 9,000 active space lasers. So sort of vaguely reminds me of Dr. Evil, you know, lasers from space. Actually, well, I guess I made that joke a long time ago. It's like Dragon does have LiDAR. It has like a laser for you know, docking with the space station. So it's like dragons with lasers. I mean, like it'd be better than sharks with lasers.
What, 9,000?
Each laser link is capable of 100 gigabits per second, and we're looking to increase that. So let's see. This is animation of all the places where Starlink is active. So obviously, a lot of the Starlink activations depend on country approvals. So as we are able to get a country approval, then you see rapid adoption within a country. And hopefully we'll get most of the rest of the countries will get the approval hopefully this year. And we'll be able to go almost worldwide.
Cool.
Some countries are probably unlikely to approve our system, but most countries we think we should be able to get to.
Like
So,
what? Like who?
and our goal this year is to activate
weird.
service in more than half of the world's population.
Cool.
So that'd be fantastic. But I do want to emphasize, because we're all going to put this presentation online, that Starlink is supplemental to terrestrial internet. It is not does not replace it. It is Starlink does really well for like low population density areas, but it is really not going to be competitive in high density cities, or it's really low density situations, which is really where the need is. So anyway, it works well with other internet providers, is what I'm saying. Then we've got community gateways. I'm told this is a town called Unalaska in Alaska. So that's a real place. So we're putting
it's the
a
square
lot more
root
gateways
of
down.
Alaska.
As we increase the number of gateways, that improves latency. So
Beautiful.
we've now shipped our next-gen hardware. That's version 4 of the user terminal. So it allows us to lower the cost of Starlink. And we'll be introducing the Starlink Mini later this year, which can fit in a backpack. So that'll be pretty cool for anyone who wants a very portable Starlink.
That's cool, man. Whoa.
And then we just opened our Starlink factory in Bastrop, Texas. So that's just a little,
And it looks like a
about
Starlink antenna.
20 minutes away from Austin.
That's cool.
And this is going to be, yeah. I guess some of you guys are part of that. Yeah. In general, we're gonna have like a massive round of applause for Starlink. That is for sure, because there's like the achievement level there is amazing. Actually, let's just have a massive round of applause. It's like, goddamn.
God damn.
Yeah. Sorry, it's hard to clap with this thing. Yeah, the Starlink achievements are really mind-blowing. So it's like the Starlink system is an anomaly in the matrix. And then we also just recently launched our first direct-to-cell satellites, and we were able to send text messages directly from a phone to the satellite and then back down again. So we did intentionally misspell these things, by the way. Although actually when I first saw it, I was like, is this real? It turns out it is in fact real.
What is real?
This is
How do we define real?
some Dogecoin jokes, basically. So yeah, and anyway, so it's kind of amazing that you can actually close
connection
the link
sucks in
between
geodays.
A phone in your hand and a satellite that's hundreds of miles away.
It's pretty cool.
And the satellite can hear the tiny signal that your phone is outputting, which is like such a faint whisper, it's ridiculous. But it can actually somehow hear that faint whisper and
That is quite
be able
impressive.
to communicate with a phone is I think, it's one of those things like, I wasn't sure, is that actually physically possible? But it is.
So phones communicate on very high frequencies. Very high frequencies don't go very far, right? Tight band is for short range communications, right? So short band, like radios, right? Higher frequencies, right? So if you want to shoot further in space, you're going to need a lower frequency to go further, right? But your accuracy goes down as you get further away, right? Can't be very accurate with those signals, but it's how we communicate with stuff way out there. Like, you need a big radio antenna, right? But the fact that these Starlink satellites can actually, I mean, the Starlink's up and down. They use optical for satellite to satellite, but up and down they're using high frequencies. The fact that they can ping a cell phone from that distance through the atmosphere is pretty damn impressive. That's pretty cool. That's a problem because there's gas in the way. There's stuff in the way. Like satellite to satellite, there's nothing in the way, so you could just beam signals back and forth. That's not a big deal. Think of fiber optic cable without the cable part, just beep 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 beep, right? But going down through the atmosphere, not just through the atmosphere like straight down, but if you have a Starlink antenna, the satellite's coming over. If it's 20 degrees on the horizon, right, you're going through way more atmosphere there. The fact that it can do that, at any angle is pretty damn impressive. That's also coincidentally the reason why Starlink antennas are flat. It's a phased array antenna designed to be able to modulate frequencies to get a correct transmission angle. Yeah. Radio and stuff, man. It's pretty dope. Isn't that screwing with airplanes? No. Why would it be screwing with airplanes? As long as it's on a different frequency. But, Hoaxstats, that's what the FCC is for. You have certain frequencies, certain bands are reserved for certain things, right? Like there was the analog signal, television, like, rabbit ears, right? If you're, I dated myself there. That was ultra high frequency and very high frequency, UHF and VHF, right? They replaced those. They moved that so because of cell phones. Yeah. True story. That's why you can't get a TV with rabbit ears no more. You have to get a converter, and it has to broadcast on a different frequency. But it is with the phone signals. I mean, what? It's a SpaceX hands-on meeting, Hando. Yep. They just wanted to resell the TV frequencies. Most likely, Booger. I mean, more people use cell phone. I mean, you know what? I don't have any data to drive this. It's just based off of an estimation, right? But I'm pretty damn sure more people use phones than watch TV nowadays. Just saying. Why do you think SpaceX will deploy laser communication? Or when do you think? They already did that, Seven. Satellites are already using optical communications. Seriously, they beam light back and forth. Because you're in the vacuum, right? Because you're up in the vacuum of space. There's not a lot of interference between satellites. So as long as you have a good line of sight between the satellites, you can do what a fiber optic cable does, but without the cable. That's what they do. They're optical. They're optical. Yeah. Crazy, right? Now, to the ground, optical isn't going to work. Once again, there's gas in the way. There's an atmosphere in the way. So they're going to use a higher frequency, which is why the Starlink satellites can talk with phones at all. I don't think your phone is designed to receive an optical signal. But basically, the Starlink is working like a cell tower that's moving by, which is, once again, that's impressive. That is an impressive piece of technology in its own regard. That's really cool. Like, super freaking cool. Not to nerd out too much.
Now, I do want to emphasize this is also not a competitor to
That's correct, Wiseman.
to phone companies. This is something that will be supplemental, so it's going to be very helpful for remote areas where there's no cell connectivity, or once in a while within a city, if there is a place that has no connectivity within a city, then Starlink will be able to communicate with phones.
That one more thing. That's the reason why, I mean, cell phone signals are very directional too, because high frequency has to be pretty accurate. This is why, like, you have bars and cell towers and stuff. Like, if there is a tree between you and the cell tower, yeah, you're gonna have a crappy signal. If you turn your back to the cell tower and you're far enough away, you're gonna get a bad signal, because once again, cell phones and cell towers are on very high frequency. They're on VHF or somewhere around there. It's very directional. That's a very important thing to understand. So, like, I mean, satellite, obviously there's just sky in between. You're not going to have to worry about it, except when it's like coming over the horizon. But if it's coming over the horizon, there's probably one above you, right? So that's another important thing to understand. There's nothing in the way. You're not going to get a tree or a building or your house, which is cool, because it's going to be always directly overhead. I mean, unless you're inside, but you get what I'm saying.
But it's, I think it's something on the order of 7 megabits per second within a cell, and the cells are sort of hundreds of square miles or kilometers in size. So it's good for text messages. You could technically do video if you're the only one, or if there's only a few people in that cell, like if you're in the middle of the Pacific or something like that. Then. But it is something that is going to be very helpful and will, I think, save lives of people. You know, if somebody's sort of hiking in a remote region and they get lost, well, now their phone could actually work, and I think it will actually save a lot of lives, which is cool. So. And then we have 7 announced partnerships. So we've got T-Mobile in the US, Rogers in Canada, Optus in Australia, One New Zealand, Salt in Switzerland, KDDI in Japan, and Entel in Chile and Peru. So, and we expect to announce a number of other telco partnerships this year. So this is definitely something where we're, again, in partnership with telcos. I just basically don't want telcos to get really mad at us. That's what I'm saying. We want to support the telcos.
Telecommunications companies.
And then, of course...
Yeah, buddy!
This is slowed down a little. So.
Yeah, that thing got out of the hole real
But that
quick.
first launch did take a while to get off the pad. I was very worried there for a second.
I'm kind of busy right now, Nova. Starship. Oh, Starship, okay. I thought the way the flame was going over it made it look like it.
I mean, when that took off, I was like, wow, I can't believe it took off. That was my reaction.
Just like that? Just like that? Are we just looking at the same thing again, or? See? Starship. We built this city on rock and roll.
So I think it's incredible that
Starship to heaven.
we took off twice last year.
It's pretty cool.
I mean, even though I've been very, closely, involved with the Starship program from the beginning, and actually, like, I lived out here. This is my primary residence for 3 years. This used to be a sandbar, basically, what we're looking at here. And now it's got an advanced rocket factory and a gigantic launch pad, and we've got a whole bunch of rockets out there. But I'm still amazed that it actually got put together and it took off. I'm like, wow. I mean, the Starship is more than twice the thrust of a Saturn V.
Beast.
It is by far the biggest flying object ever made.
Yeah, buddy. That's awesome.
And
when you think about it like that.
With some upgrades down the road, it'll actually be, I think, probably over 20 million pounds of thrust. And Saturn V is 7.5. So it'll end up being 3 times the thrust of Saturn V. And it's going to fly a lot.
That's pretty cool.
It has to fly a lot. So it's going to end up flying several times a day.
Is that good? Yeah.
From many different locations in the world.
Yeah, that's pretty
And
good.
I think there's a pretty good chance that it does Earth-to-Earth transport as well. Because the fastest way to get from one place to another on Earth is, to get from here to the other side of Earth is an intercontinental ballistic missile. But just make sure you delete the nuke and add the landing part. Basically, that's the fastest way to get somewhere.
It's easy. You should do that.
Yeah, wow.
Yeah.
And then between Flight 1 and 2, we made a number of massive upgrades. So there was obviously a massive upgrade to the launch pad. So we've got like our mini Niagara Falls here.
Niagara Falls. Slowly I turn.
I mean, the water pressure is so much that if it went straight up, it would actually destroy the rocket. That's how much water pressure it is. So it's like, wow. And
it's
it worked.
like, wow.
Actually, went and looked at one of the first things I went and looked at after the second launch was to check out the launch pad, because obviously after the first launch we dug a pretty big hole, and honestly it looked like it looked like there was no damage at all. Like you could just launch again basically for the pad itself. So it's great work by the team to radically improve the launch pad overnight. Yeah. The people always want to use the Statue of Liberty for stuff.
Anything but the metric system.
Statue of Liberty
man.
is not that big. I was like, been there. I actually climbed up the Statue of Liberty in the tiny staircase a long time ago. But anyway, this is a big rocket, and it will get bigger over time.
Great story,
So,
man.
Yeah.
It looks like
So I don't know
Godzilla,
if you guys watched
but due to international copyright law, it's not. But we should run like it is Godzilla, though it isn't.
Kong versus Godzilla. It's like one of the most insane movies I've ever seen, but it's like kind of entertaining in its sheer madness. The crazy thing is that our launch tower is bigger than Mechagodzilla. And it's going to do basically like the same thing, but with the arms, like catch the rocket. And when I tell people, yeah, we're going to catch the largest flying object ever with giant mechanical arms, they're like, there's no way that's real. I mean, we could give it legs, too.
Please.
just give it legs and have it tromp around. That'd be pretty cool.
I want this.
So,
I want this.
and then we're also going to build a second tower. Yeah.
Yeah, baby. Rip.
So we're gonna really be launching a lot, and we're gonna be upgrading one tower while we launch from another tower. So 2 towers is important. And there are actually so many upgrades between Flight 1 and 2 that it would actually take it like hours to go through them all. But one of the biggest upgrades was going from hydraulic to electric actuation of the engines. So that actually saved a lot of mass and complexity.
Oh, that's killer, man.
Yeah. The electric TVC, I mean, it was just, this is one of the biggest upgrades. We also massively upgraded the heat shield. The engines themselves were massively upgraded. Literally everything on the rocket was, there might have been thousands of upgrades between Flight 1 and 2. So really gigantic improvement between Flight 1 and 2, and Also, obviously, many improvements between Flight 2 and 3, and then we've got a whole
His dreams, his desires,
development
his most
plan
intimate
to, like I said, ultimately get to a fully reusable rocket that does over 200 tons to orbit on a regular basis. Full reusability.
Huh? What? Sorry.
Yeah. Hot staging.
Yeah, buddy.
I mean, hot staging was a change that was basically, I don't know, just really within a space of like 3 or 4 months, maybe less.
So cool.
Going from, or roughly that, going from previously just kind of like separating the rocket without anything, and to actually lighting the upper stage engines while the first stage engines are still thrusting. And not blowing up the ship, which is
Thrust.
That was an amazing achievement. So I was like, wow,
that's awesome,
and it worked.
So freaking cool.
I was like, wow. So
it's like wow.
So then let's look at Flight 2.
Reading Isaac Asimov.
Attention
Carmine.
all operators on countdown 1. This is the final go-no-go for Flight 2 of Starship. NRT0.
Watch this. This video is sick, dudes.
Raptor 1.
Go.
Raptor 2.
Go.
Stage 1.
Go.
Stage 2.
Go.
Copy. Go for flight. Clock is rolling. 10, 9, 8, 7,
Bruh.
6, 5, 4, 3, 2, 1. We have liftoff.
Chad, it's making me feel feelings. I like that. That's pretty cool. That's badass, man.
Boost ratchet cut off. Stage separation.
Damn, that's cool. Bye-bye. That's when it blew up. It went right to its thighs. Then it blew up. And then that blew up too. Oop! Whoops. Yeah,
So-
it doesn't suck.
Yeah, big round of applause, guys. Wow.
Nah, Twitch Plus, that actually happened. It was pretty awesome. It was pretty cool.
So Flight 2 actually almost made it to orbit. In fact, ironically, if it had had a payload, it would have made it to orbit. Because the reason that it actually didn't quite make it to orbit was we vented the liquid oxygen, and the liquid oxygen ultimately led to fire and an explosion, because we wanted to vent the liquid oxygen because we normally wouldn't have that liquid oxygen if we had a payload. So ironically, if it had a payload, it would have reached orbit.
Huh.
And so I think we
Yeah.
got a really good shot
Incorrect
of reaching
fuel
orbit
flow.
with Flight 3.
Yep.
And then a rapid cadence to achieve
Okay.
full and rapid reusability.
So, just real quick. Starship uses liquid methane and liquid oxygen. They had a lot of liquid oxygen on board for Starship, right? So let's talk some basic rocket science here real quick, okay? If Starship had 100 tons of payload, you'd fill the tanks up to the brim, right? But you don't do that. You don't do that if you have nothing on board, right? It's like if you're going on a road trip and it's just you in a car, right? I mean, you're going to go further with a tank of gas than if you had like 4 people and all their luggage in the trunk, right? Same idea, right? But with rockets. So what they most likely did, but see, here's the thing with rockets. If you don't put anything up on that, up there, if you don't have a mass on board, like if Starship isn't a similar mass to what it would be with payload, right? And you launch it basically like with the modified fuel load for it to get to orbit with no payload, Super Heavy's going to accelerate it too quickly, and you run into aero problems on the way up. Basically, it'll go too fast. You don't want to get re-entry heating on the way up. So what SpaceX did was they had liquid oxygen. They filled up the liquid oxygen tank, basically full, and as Starship was going, they vented it, right? But the problem here, they were venting it overboard, so they could basically make sure that Starship got to orbit with the right amount of fuel, right? You don't want to have it have too much fuel, because then when it tries to come down and land, it's not going to work, right? But you don't want to not have enough fuel either. So here's the thing: if you run out of oxidizer and you basically screw up the ratio into the rocket engines of liquid oxygen to liquid methane, they have to go in at a precise ratio. You have to maintain that constant pressure. If you run out of liquid oxygen but keep moving methane, you basically do the rocket equivalent of flooding the engine. Flooding the engine is not good for it. Yeah, not good. Not good for it. Anybody that, if you like old cars, for instance, and you have a car with a carburetor and you just keep pumping the gas and you try to start it, it's going to get flooded, but you also could get a backfire. It'll backfire, it'll detonate out the carburetor out the top, and you get flames shooting out the top, right? That, but with rocket engines, usually leads to a much bigger explosion, right? It's the same idea. It could lead to a cavitation event inside of the rocket motors. Cavitation events can lead to detonation. Detonation inside of the rocket motor is like rod knock for a rocket engine. Really not good for it. Really bad. Dude, that's really bad for it. It makes it blow up. Yeah. It'll go right to your thighs, and then you'll blow up. Just got back. What's neat with the update? Zay, they were using LOX's ballast for IFT2, and using LOX's ballast, they vented the improper amount, and the engines ran fuel rich, and that was the end of that. Yep. Yeah, it was, they vented, the computers on board Starship vented too much liquid oxygen, and they didn't have enough to get to orbit, and it ended up flooding the rocket engines with methane, and this kills the rocket. I thought it just said it started a fire. I mean, also that. Sure. Did you say already? Remember when seeing the readouts in the ox? Yeah, I saw that when on the actual flight, the liquid oxygen was going down. We did see that when it happened. Yeah, incoming torpedo. That's right.
And I mean, the mind-blowing thing is, like, there is an actual path that we are on to make life multiplanetary. Can you friggin' believe that?
Yeah, it's pretty cool.
Like, what?
Well, drifting, they probably won't make that mistake next time, huh?
Yeah, we just got to get it done before civilization ends. But like, I think it's going to happen. Yeah, right here. So, anyway, so in terms of getting there, we obviously want to accelerate the production and testing, get to a high cadence. For any given technology development, it is. How many iterations do you have, and what is the amount of time between each iteration?
Probably bad.
So every time
or
we
just
launch,
get the vent right and have it not catch on fire.
We learn something more. So increasing that cadence of launching and testing, and it's always better to sacrifice hardware rather than sacrifice time. Like, time is the one true currency. So it's sort of the fastest path to, as I was saying earlier, rapidly reusable, reliable rocket. Yeah. So, and we've got a block, sort of a version 2 ship that will be more reliable, better performance, endurance. We've got a version 3 ship design that will stretch be even taller. probably end up being, I don't know, 140 meters before it's all said and done, maybe 150 in the end,
It's a beast.
in length.
500
So,
feet tall. 50-story building. Okay.
Yeah.
Okay.
So it'll be even taller than it currently is. Yeah, and so with flight 1, the goal was not to blow the pad up and ideally get some distance, which we did. With flight 2, it was to get past staging, so we achieved the goal of getting past staging and almost to orbit. And then flight 3, we've got well, we want to get to orbit, and we want to do an in-space engine burn from the header tank and prove that we can reliably deorbit. We want to do a tipping point header domain propellant transfer. This is important for the NASA Artemis program. And we want to also demonstrate the payload door for the sort of PEZ dispenser for delivering the Starlink, the V2 non-mini, actually probably I guess V3 technically, but the really giant satellites to orbit.
Can I hear that one more time, dudes? I gotta listen again.
Past staging and almost to orbit. And then flight 3, we've got, well, we want to get to orbit, and we want to do an in-space engine burn from the header tank and prove that we can reliably deorbit. We want to do a tipping point header domain propellant transfer. This is important for the NASA Artemis program. And we want to also demonstrate the payload door for the sort of PEZ dispenser for delivering the Starlink, the V2 non-mini, actually probably I guess V3 technically, but the really giant satellites to orbit. Yeah. So, like I said, the mass orbit ultimately of Starship will be, over time, I think millions of tons of payload to orbit. So, I mean, compared to present day mass to orbit, it'll be more than 1,000 times. I mean, more than 1,000 times greater than mass to orbit currently. That's what it will be eventually, or needs to be. So we also want to demonstrate on-orbit refilling. This is very important for the NASA Artemis program. So we're very proud to be part of the NASA Artemis program. I'm always incredibly grateful to NASA for their support and for trusting us to take astronauts to orbit, to take cargo to the space station, and to be an integral part of getting astronauts back to the moon. One of the other questions I get a lot is, did we really go to the moon? I've gotten that from a lot of people, and I'm like, yes, we went to the moon. More than once, in fact. But the crazy thing is that it's been over half a century since we last went to the moon. So,
Yep.
I think maybe that's what causes people to be skeptical. Like, how come we can't go to the moon now?
It's because for the last 50 years, you have your head up your cooler. Come on, Pelican. Come on, Pelican.
It was 66 years from the first controlled powered flight of the Wright brothers in 1903 to landing on the moon in 69. So only 66 years. But,
Nice.
like 50 years have passed since we last went to the moon. But now we're going to go back there, and we're going to go back there soon.
Hell yeah.
And we're not going to go I think, the next step, I think, is to build a moon base, like Moon Base Alpha. Make sci-fi real. Remove the fi part of sci-fi. So,
John Madden.
but now, in order to go and land on the moon, one of the technical challenges we have to solve is orbital refilling, where we dock, the starships dock on orbit and transfer propellant.
Sorry.
Now, we've gotten very good at docking because we
Football.
dock with Dragon to the space station, which is actually more complicated than docking with our own spacecraft. So we have a lot of expertise in docking, so I'm confident we will solve this, and we just ideally want to solve it hopefully by the end of this year, but certainly by next year. And that's a big deal. This is one of the fundamental technologies that's necessary to build a city on Mars and to have a moon base. And then, yeah, we'll also be launching some very big satellites.
Pez dispenser.
World's biggest Pez dispenser.
So, people were talking about, well, why didn't they put a payload on IFT2? Why didn't they do that? And they don't have it figured out yet. They don't know how to do that yet. They're still figuring this part out. That's the reason. Yeah, they're gonna. Starlink is basically. I mean, this is gonna be a weird way to put it, but Starlink is basically an excuse to build this thing. The initial excuse, right? There has to be a use case for it, right? Right now, Falcon 9 is doing the majority of the work, right? And no, it's doing all the work. But a reusable, launching and maintaining a network that big favors reusability, right? That's the use case. Starlink is basically the revenue that's going to make Starship do, right? It's going to make it do the thing, So that initial versions of this thing is going to have that Pez dispenser on there. Wait, look at the Pez door. What about it? They could still put a mass simulator. I don't know how you're going to fit a mass simulator in that thing. Fruit snack dispenser. Yeah, Let me see.
And then, yeah, we'll also be launching some very big satellites. World's biggest Pez dispenser.
Interesting.
And we do hope to do this by the end of this year.
Please.
And then, yeah, more about the NASA human landing system. So, as I said, we're extremely grateful to NASA for entrusting us with a fundamental part of the Artemis program. We want to make sure we do a great job for NASA.
I wouldn't try to eat those.
And really, we are a very fundamental part of the Artemis program. So if we do not succeed, which we will, but in order for the Artemis program to succeed, we must succeed with Starship. Like I said, we actually want to far exceed what NASA has asked us to do. So we want to go far beyond the NASA requirements and actually be able to put enough payload on the moon with enough frequency that you could actually have a permanently occupied moon base. That's the next really big threshold from Apollo. Is have an actual moon base.
Please.
I remember seeing this kind of cheesy sci-fi show a long time ago called Moonbase Alpha. I don't know if anybody's seen that, but the moon actually drifts away from Earth. Now this is not going to happen, but it was a cool show, Moonbase Alpha. But we need a real Moonbase Alpha, and we're going to do it.
Football.
So then, as I was saying, this is the long-term goal. This is what we want Mars to look like: is starships coming and going.
It'd be nice, It'd be pretty
an
cool.
incredible, beautiful Mars city, and a flourishing civilization on Mars.
Hopefully.
Ultimately, we can transform Mars into an Earth-like planet with terraforming. Just needs to be warmed up, really, and then it could be ultimately an Earth-like planet, and we could bring the life from Earth. We could extend life from Earth to Mars, and really, it has to be humans, because it's not going to be the dolphins. But we can bring all the creatures with us.
What is he, a Jets
and we can
fan?
ensure that life on Earth continues on Mars, even after Earth becomes unlivable in the distant future. So anyway, I'll go into questions.
Oh, no, oh. Hey, that's pretty cool. We got a cause for IFT2 failure. That was worth it. That was worth that whole freaking hour right there, man. That's pretty good. They cut the fun part. Oh, those are employees. That's not press. So I bet you the questions were actually pretty good. But, yeah. Dolphins, Hitchhiker's Guide. Yeah, whatever. Yeah, that's good too. Don't forget to bring a towel. Why doesn't Starship have solar panels? I think the earlier version 7 won't have them, and then they'll probably find a way to outfit them sooner rather than later. Sorry, came in late. What caused the IFT2 failure? They were venting liquid oxygen, and it basically caused a fire. And then my guess is that a detonation in the engine from running fuel rich. You're basically spraying fuel out, right? And then if you have oxygen leaking out the side, and the engines end up running fuel rich, right? If it finds something that's hot, spoiler alert, the rocket engine's hot, you're gonna get an explosion. They were using LOX as ballast, but he said they vented too much. So, I mean, it's gonna find liquid oxygen doesn't blow up by itself. It needs to combine with something. So, if the engines are running fuel rich, that means they're spraying methane, unburnt methane out the back. That's going to find the liquid oxidizer that you vented. It's going to atomize with it because you're in low pressure, right? Because it's almost into space, right? And it'll find something that's warm and explode for you. That's my guess. Yeah, usually when you run rocket engines fuel rich or oxidizer rich, they blow up. But if you have oxidizer outside of that environment, you're spraying unburnt fuel into a liquid oxygen vent that also causes explosions. Think SN4, if you guys want to go look up the SN4 footage. That. You vent too much, you get Apollo 13. Now, that's what happens when you stir the tanks. Don't stir the tanks. Especially don't stir the tanks after some numbskull drops it and cracks the Teflon seal on the tank. Yeah, and then just says, oh yeah, it's fine, and puts it in the spacecraft anyway. Yeah, that causes a problem. Turns out space flight hardware is really delicate, and if you drop it on the floor and then just put it in the spacecraft like nothing went wrong, bad stuff happens. That's weird. Huh. Yeah, don't drop it. Elon, probably. Don't drop it. How fired was that guy, though? Yeah. That also is why that Delta II booster exploded in 1997. Some guy dropped one of the boosters, and it caused a microscopic crack in the SRB. And there's this thing about rocket engines for the uninitiated. The thing about rocket engines is that they shoot out a lot of fire out the bottom. Out the bottom. If the fire comes out the side, you did something wrong. And in Starship's case, fire came out the side. Yeah, so, you know. My favorite part of that whole presentation was the gimbal stuff. Seeing the engines just zip around, that's the best, dude. Look. Yeah. That's awesome. 4526.
Beta number. Really be launching a lot, and we're going to be upgrading one tower while we launch from another tower. So 2 towers is important.
Shouldn't they keep it to simulate the weight all the way? Sorry if I'm kind of lost for the reason for venting. Well, they're using it as ballast for ascent, particularly well it's a full stack, Miguel, and they're probably venting it overboard on the way up. So it's basically used to keep your thrust to weight ratio in check. And because Raptor engines can be throttled, I don't think it's a problem. But like on Starship, but with the first stage, you don't want to go too fast with this thing. Simultaneously, you don't want to go too slow. You go too slow, you're not going to make it. You go too fast, the aerodynamics will rip the thing apart, right? Hey, Just Space. I'll read that in a second. So they vent it, and the other thing is that they're probably venting it. They're probably venting the locks to basically make. Okay, so first of all, it's preventing G load. You don't want to exceed a certain amount of G-force load on the boosters. You don't want to accelerate too fast, especially with the second stage. Even with the second stage, even though it's not really aero because the second Starship's way up out of the atmosphere, right? But there's still just acceleration. You know, at the end of the day, it's wires and stainless steel and batteries and rocket engines and fuel and stuff. You can compress stuff under load like that. Especially if you accelerate like too fast. If you're pulling 9G acceleration, A, that's unrealistic, especially if people are going to be on board, and B, you could break things. Basically, the whole thing can sandwich. If you really want to know, you could sandwich the thing. If you have too much power out back, Miguel, it'll wreck the whole thing. So basically, they were venting locks like that to simulate a proper ascent trajectory. Also, they wanted to make sure they have the right amount of fuel for entry, descent, and landing. Anyway, having the right amount of fuel through descent and landing is super important because, like, okay, so think about it. They have those header tanks up at the front. The header tanks are basically there for the deorbit and landing burns, right? For Starship. Theoretically, this hasn't happened yet, right? The main tanks, the header tanks are inside, and there's a vacuum medium between them and the outer skin of the vehicle. They're not, like, up against the side like the other fuel tanks are. The whole bottom of Starship is a structurally integral fuel tank. So methane tank and a LOX tank, and then the two header tanks are up in the front. There's a vacuum around those tanks, and they're obviously in the shade because they're inside of the nose cone, right? So you want to, if you had fuel in the regular fuel tanks for re-entry, right? You could potentially heat, if like you had extra fuel, you could heat, the re-entry heating can heat up that fuel, and then you could, now your tanks are overpressurizing. Now, don't get me wrong, you can vent, but if the flux of heat into the fuel inside of the vehicle exceeds the flow rate of the vent, right, you overpressurize the tanks. Basically, the vent can't vent the expanding gases fast enough, right? So you want to make sure you have the proper fuel load, and you want to make sure that you have the fuel inside of the header tanks. So that's probably the other reason why they were doing it. Does that make sense, dude? Also, I want to see those engines zipping around. Just Space, what did you say? Sup, EJ? Got a lot to talk about. Working as a propulsion engineer at Michoud for about 6 months now, and it's pretty cool. I can definitely say Core Stage 2 and CS3 are coming along quite well. Yeah. Yeah, buddy. That's awesome, man. Just Space. I am bumming about the delays, though. But also, the hilarious part about the delay is that SLS is in the bottleneck. Yeah, they are using it for ballast, though, Miguel. They are. They're using it for ballast to make sure your thrust to weight doesn't go. If the rocket goes too high too fast, it'll explode. Yeah, you'll break it. Yeah, SLS ain't the bottleneck, boy. That's what I got out of that conversation. But man, that pissed me off, dude. We all saw it coming. We're actually happy that we aren't the bottleneck. You damn right. It's because it's a good launch vehicle. You just need a better upper stage. We need that better upper stage. But it's coming. It's coming. I know. I've seen the pictures. I see the pictures. I'm observant. Very observant man. All right. Anyway, I wanted to see. Oh, Just Space, check this out. This is from a SpaceX hands-on meeting today.
They're actually.
Oh, that's so cool. Real talk, can SpaceX go fully vertical and make the whole thing? Make the whole what thing, Wolfie? They do make the whole thing. They make the whole thing. Sick. Also, the EUS is what I'm principally working on. Oh. Are those the welding confidence articles? Are those coming? Those coming good? Uh-oh. Uh-oh. How does he know about that? How does he know about that? He's not supposed to know about that. Looking good? All right, man. Hell yeah. Hell yeah. Yeah. All right. You got to test that jig somehow, dude. Is it electric? That's electric thrust vector control, Crypto. To my knowledge, there's only one other rocket that has electric TVC, and that's, well, Electron. Actually, I don't know. Electron has electronic fuel injection. I'm not sure if the thrust vector control is electric as well. It actually might be hydraulic. I don't know. Fact check. Go. Kowalski. Analysis. I'm going to sit here and look at this. Oh, that's badass. How many Starship engines have they destroyed? And is their production quicker yet? Their production is quicker. How many have they destroyed? Well, I don't know. How many are in that picture? 39 engines there and 39 in another one. Cute dancing toothless babe. Yeah, baby. 200 tons to Leo from Starship and 150 meter tall Starship. That's insane, dude. It's crazy. Starship is going to be as big as Super Heavy when this thing is done. Yeah, and I'm not sure how to feel about that. I think that's going to look a little weird. Are they using electric motors with screws to cause the actuation? Yeah, I'm not sure, Journey. I mean, a screw jack is what makes the most sense because you're going to get the most amount of torque from that, right? But screw jacks don't work very quick now, do they? Unless that thing is like, you know? Yeah. Here, hold up. Oh, adiabatic compression. Here, let's go back over here. Here's what I'll do, chat. I need you to clip this for me so we can put it in mission control. I'm going to go off the screen for a second, right? I'm going to go off the screen for a second. And we need a clip here. All right, when they start showing the thrust vector control, I'll see if I can get the mouse off the screen. Oh. That's pretty cool. Okay. I know, isn't it cool, man? Somebody clip this. Electron is electromechanical, thank you. Yeah. Oh, that's so legit, dude. Man. That's amazing. Bro, I could look at that. I could watch that 1,000 times. That's so cool. What's a white coating inside of the nozzle? So, the white coating in the nozzle is basically a good indicator that that rocket engine has been fired and is past acceptance testing. Basically, what that is it's a cleaner. It decontaminates the inside of the rocket engine. That's the best way to say it. It's basically an industrial degreaser, but it's like an aerospace grade industrial degreaser. Yeah, they spray it inside of the nozzles after the thing's been fired. The reason why is you don't want to get corrosion inside of these things. Remember, you're using liquid oxygen. Liquid oxygen oxidizes things. So, Raptor engines don't, but think about like if you poured liquid oxygen on iron. You want rust? That's how you get rust really fast. You think salt's bad? Yeah. So Basically, when the engine is done firing and they're safe, they save the thing, they take it off the stand, and they move it around for transport. They spray basically a degreaser in there. It's not a degreaser. I forget the name of it. I forget what it's called. Oh, thank you for the clips, dudes. Thank you. We got to make that into a GIF somehow. In the biz, you call that NVR. Yeah, I forget what the acronym is for Just Space, and I'm just coming off being sick, so I'm not as sharp as I usually am. But yeah, I usually remember the names of this stuff. Non-volatile residue. There you go. Yeah, they do that with all kinds of aerospace components, but you see it on the Merlin engines too, on Falcon. And you can see it in this GIF right here. In that you can actually see if how much these things have been fired, or if all of them have been fired. I think all of them were fired on this one. So it's a coating. Yeah, basically. Or bare metal on metal, cold welding. Yeah, there you go. Oops, sorry, wrong window. My bad. Stellar, strangely enough, that's kind of topical, but yeah, no, all good, man. Don't worry about it. Especially oxygen hardware, because in a pure oxygen environment, metal becomes the fuel. Yep. Yeah, Just Base. I was actually telling people about how, if you have nitrogen tetroxide backflow in your hypergolic helium pressurized systems. Yeah, if you have hypergolic backflow, specifically with MON 25 or NTO or N204, and it hits some metal at high pressure, you made a nice hybrid solid rocket booster. Yeah, that's not good for it. I don't know how that would have been topical recently. Hypergol smoke. Don't breathe this. Hey, what's up, Matt? 106 months. Dude, how about that shout out from John Krause, man? Bro, you're doing it. You're freaking doing it, man. That's awesome. That's pretty cool. Matt got shouted out by John Krause for his photography, guys, on X. Yeah, it's like 2 ppm or something, Stellar. It's something absurd. Hypergols are really bad for you. Turns out that if you have a titanium fitting and nitrogen tetroxide pressurizes up against the titanium fitting or a titanium valve, the titanium valve becomes rocket fuel. That's weird. John and I have been chatting more and more lately. He's a chill guy. John's good people. Yeah, he's good people, dude. He's cool. I also have a shirt like this in real life. I don't know if you knew that. Anyway. That was the hardest part during the shuttle prep. Yeah, that's right. Yes, NTO and MMH contamination. Yep. We were chasing New Glenn the other morning. That's cool, man. Is hydrazine a hypergol? Hydrazine is the liquid fuel component in certain hypergolic propellants. Yes. It could be monomethyl hydrazine. It could be aerozine 50, which is another compound of hydrazine. Yeah. Basically, it could be unsymmetrical dimethyl hydrazine. Jesse, we gotta cook. Yeah, and UDMH usually combines with N204, or just, I think, straight NTO. But you could have MON 25, which is, I actually read about this the other day. MON 25 is mixtures of, it's mixtures of different types of hypergolic oxidizers for better efficiency, which is actually pretty cool. When will New Glenn launch? Judging by the hardware that I've seen, Journey, probably, if we're lucky, the end of the year, from what I saw. But I warn you, they don't just have one New Glenn booster. All right, the one that we saw roll out is not the only one in the pipeline, from what I can tell. I only power my rockets with Einsteinium. The absolute madman. Matt, you can just post it in here. I don't care. It's fine. Don't worry about it. I've looked at enough of your pictures on here. But I want moon landing now. New Glenn. The fact that the BE-4's got something orbital before the Raptor is such a hard flex. That sucks. That sucks so hard, dude. Fair, I didn't want to self-promote. I appreciate that, but just post it, bro. It's fine. You have my permission. And that is unwavering. You can post it anytime. I don't care. I don't care. Post your stream in here, dude. I don't give a frick. I don't give a frick. I'll go to the loony bin too with you, bro. I don't give a frick. Anyway. Will humans land on Mars within 8 years? I think we'll get something to Mars in 8 years, App. Whether it's with humans or not, I don't know. That's a tough thing to do. Really difficult. We're talking a factor of difficulty that most people don't really understand. Dante was such a legend. Oh, yeah. Better, what do you think? I look up and what do I see? The freaking king of the jungle. We got to hang out again one of these days. I miss chilling with you. It's been so long since East. I'll be down in Florida the 25th through the 30th. I'll meet you at the Daytona Beach Buc-ee's, man. Because I'm going to watch Scary race at the Rolex 24. Also, the fact that Newglen's is named Freedom and the fact that it also kind of looks like the Freedom rockets from your mission mode save, just going to put that out there. What the frick? Don't tell me that. Don't tell me that. I'll shoot you a text later. We can figure stuff out. All right. Don't tell. Are you screwing with me? I immediately thought of you when I saw the name. Oh. Freedom is a good name. But I've been too busy with like all the planes lately, so I haven't seen Spaceflight Now for updates. You didn't know that? I knew the name was Freedom, but I also have a rocket name. Just because I also have a rocket named Freedom from my mission, from the mission mode saves, doesn't mean that doesn't mean they're like, yeah, we should call it that. How long have we been doing SpaceX talk? I don't know, about an hour, maybe an hour and a half. That's probably exactly what happened. I do know a lot of people that blew. Link perms, sir. For what, Karmas? What's up, dude? Jeff watched the mission mode save during COVID. Confirmed. Just to be very clear, okay? I'm just going to air this out, all right? If somebody ever, and I'm putting this out on the internet, so I can't take it back. If somebody in the actual aerospace business saw an idea of mine, right? And we're like, hell yeah. Or like a name or something. All I want is bragging rights. All I want is bragging rights. That's it. The assurance that, you know, some of my ideas are actually getting used in the aerospace industry would be vindication enough for me. That's fine. All right? So now that that's out in the open, yeah, we're good. I just thought I needed to say that. Did you catch the X-58 reveal? X-59? Yeah, we watched it, dude. Mm-hmm. Karmas, what are you linking? Oh, the Endeavor exhibit. Yep. Pretty cool. Yeah. I'll ask my boss on Monday if we can rename our prototype Citation Ascend. Let's be real. If somebody in the aerospace program rolls out with their prototype and the internal name for it is Frank, we know what happened. All right, we know that was us. All right. 5 years from now, we were putting a space plane on top of New Glenn called Dart. Hey, wait a minute. All right, Just Space, check this out. All right, here. Just in case anybody else hasn't seen this. All right. Check this out. All right. This is a picture of Dream Chaser at Plumbrook, okay? That bracket looks awfully familiar. That's all I'm saying. That's all I'm saying. That's all I'm saying, okay? That's all I'm saying. That bracket looks awfully familiar. Jeez. Dude, that's all I'm saying. I'm just going to keep saying it. That looks awfully familiar. All right? That's all I'm saying. Okay, here. Look. This was a mission mode save from a little while back, fellas. Take a look at this. I had a small space plane in this mission mode save. Okay? Bro. What the actual frick is going on here? All right? What the actual frick, Sierra? Are you kidding me? All right? Look at when this screenshot was taken. Okay? Look. All right? That's bullcrap. What the actual frick? What the balls is this? Damn it. Their bracket works very different than mine. But it looks the same, okay? Just means it was a good design. Like I said, Crazed, nobody at Sierra probably said, oh, yeah, that's a good idea for Kerbal. Let's do that. Let's write that down. More likely it's that it's vindication for me that I'm on the right track, that I'm building stuff correctly, that I understand the problems associated with spaceflight and can fix them in Kerbal, not in real life. In Kerbal, though, that's a hard game to play, man, all right? All right, hey, XTC with the 40 months, and Barry with the 25-monther. Hey, Barry, how are you? I appreciate you being here. Thank you very much for watching and for the 25-month resub. Thank you very much. Yeah, Barry. What's up, man? What's happening? He's beginning to believe. All right. Good Barry or bad Barry? Well, it's just Barry. That's all that's there. It's just Barry C97. He's been watching us here for a extremely long time. He's a great guy. Oh, hey. Found one of the videos I took of the shuttle landing at the SLF. Want it posted somewhere for nostalgia? You post it in here, okay? Real talk. I would love to see you try to do the mission mode save again. Probably the best Kerbal engineering you've ever seen. So, Just Space, we've been cooking up some stuff. I've been trying to get my hands dirty with the Kerbal 1 editor again. Hey, Abstate, thank you. I've been here since, what, like 2012? Yeah, Barry, Lego Studios, dude. Yeah, no, I remember. You've been here a long time. I've met you in real life, okay? Yeah. That has no bearing on time, but also, that's a big deal. It's a big deal. Yeah, Just Base, I agree. I think it was excellent engineering. I just gotta... Did you date? Yeah, no. It was at a con. Batman, jeez. I kind of want to do more Kerbal 1 mission mode. But I have to get back into it, dude. Believe it or not, playing other games made me kind of soft in the editor. We got to fix that. What is mission mode? Nader Hunter, mission mode was a rule set that I played by during the pandemic, and it was insane levels of difficulty for Kerbal. Insane. No reverts, no quick saving, no quick loading, and you have to reuse things. Okay? You have to build the rocket system out. And then I was absolutely insane enough to have chat budget my programs. We would vote every week on the program's budget, what types of tests we're doing, what missions we're running, and then on top of that, it was a career science mode save in KSP1 with all the difficulty settings turned to maximum. It is the most difficult version of Kerbal that I've ever played. It was really tough. No modded parts. No mods. Completely vanilla. It was very, very hard. Yeah, I know, Just Space. Yeah, I know. Yeah, designing by committee was stupid. That was my big mistake. But check it out, dudes. Like, I made entire lift systems, service structures, all the cranes, all the vehicles for the launch pad. The launch pad was reusable. The stages ended up being reusable. I made a little mini shuttle for them. There you go. Yeah, see? Check it out. Freedom. See that? Freedom rocket. Yep. I used a pedestal-based launch pad, mobile service structures. The crane can build the rocket on the pad, and then it moves out of the way. This is all in stock KSP. Yep. See? Check it out. Nader, it was hardcore, man. You think what I do in Kerbal is nuts now, dude. That was the most hardcore thing, dude. I even had, like, hangers, and, you know, you got to pick the stage up off the truck. See? Pick it up right there with the crane. I have all the integration vehicles for moving stuff around. Yeah. You had to refuel the rocket. If you reused it, you had to fuel it. Well, I want to get back to doing it, fellas. I want to get back to doing this stuff. It's really fun building rockets this way. It's very, very, very challenging. Yeah, there's a Freedom. That's a Freedom 7 rocket. So Freedom 7 is the white one. Freedom 10 is the orange one. I actually integrated out. I did all the systems engineering out to make the pad have an adapter so you could launch either one. I made think almost like what ULA does with Slick 41. They can switch between Vulcan and Atlas. Same idea. KSP2 is good context. It's fun to play, but once again, it's still early access. Going to need more time to flesh stuff out, but you can't really play like this in KSP1. That's the thing. Yeah, see? I even put serial numbers on all my stages so you could see what stages have been reused and what hadn't. Yep, see? I have my little mini shuttles stored in a mini integration building over here. So basically, I had a crane, and the crane could pick the thing up, put it on the truck. The truck has the bracket, right? And you drive the truck over, and you back the truck in. Crane can pick the bracket up, attach the bracket to the shuttle, and put the shuttle on top of a rocket. Over here, this weird kind of llama-looking structure, that's the service tower for it. So the service tower, you know, I would have my Kerbals drive up to the pad, drive up to the launch complex, right? And the service structure could roll to the stacked vehicle, and we would close the platforms in on it, and you could get into it. You could get the Kerbals inside. Yep, see, there's the Dart adapter right there. Oh, yeah. Yeah, it was fun. There's the flying cigarette rocket. I still think the Taurus wing could work in real life. You'd have to design it a certain way, but it's possible. That stage is a flyback stage. Basically, it flies business end like Falcon 9. It does a boost back burn, and then instead of like coming down and landing, it has a toroidal wing, so a wing that's shaped like a donut wrapped around it with stators. And because the center of mass of the booster is over here when it has no fuel left in it, I have two jet engines on the side with the jet engines actually facing away from the rocket engines. And it kind of would have grid fins on it, but not. That's actually a rudder and two horizontal stabilizers. So the thing would boost back, come back down through the atmosphere, and then it would fly and land at the pad. It had tricycle landing gear. So I have a set of landing gear underneath the jet engine, and then in the aft skirt, there's another landing gear, and it would just land like an airplane. Yeah. We called it the flying cigarette. Yeah, see? Experimental booster. Yeah, that was actually one of the easiest ways to reuse a booster that we figured out. Yep, see? Landing gear there. There's another one right there. You can't really see it. Yeah. I want to see those. There's the truck and the reintegration bay. There's Dart. Dart ended up killing Jeb, which is annoying, but what are you going to do? I didn't design it good enough for reentry. Do you have Discord? I have like 40 pictures. Yeah, dude, of course. Jump in there, and I think I have a category just for that. Yeah, I did all this, integrating every single payload, building transfer vehicles, lunar transfer vehicles to the moon, refuelable upper stages, reusable landers. Yep. All that. I got architecture to the moon using Earth Orbit Rendezvous and building every single payload on every single rocket. I even had light towers so you could launch at night. Pretty crazy, huh? I'm trying to find us a picture with the service gantry. Yeah, see? All that. There's deploying a dart right there. Yeah, Jazzos, maybe. Yeah, there's 2 darts docked to my space station in the mission mode save. All this with chat funding the missions, career mode, no reverts. Do it right the first time or it blows up and you lose cash. And then I made cranes. That's what I was working on. Nobody wants to see me make cranes, though. Every time I do a stream where we build cranes in Kerbal, everybody leaves. I was working on building lattice cranes so we could build the actual launch pad as well if we really wanted to. That would make it so I could reconfigure the pad easier. We could reconfigure the buildings. You could use it to pick things up, whatever. Yeah, see? There's the gantries. The service gantries for this are closed. Now, did I just make arbitrary surface gantries for this? No. Actually, no. These were used for if I needed to mark the booster. Like if I needed to change the lettering on the booster, or if I needed the Kerbal to run a strut to hold stuff together. I actually used the service gantries for something. There's 3 of them. There's 3 decks. One's at the top of the first stage, one's at the top of the second stage, and then there's a crew access arm up there in the top of the tower for getting in this thing. Yep. Look at the bracket. See what I'm saying? Man. Yeah, and see, the Kerbals would get into the tower, they'd go up to the top, and we'd lower the gantry, and they'd get into the craft. See?
Discovery, go at throttle up.
Moses, 2 months. Thank you. Appstate with 500 bits as well. Thank you. Yeah, see? Yeah, dude, look at that. Lattice crane. That was awesome. Yep, there's Dart. Gotta translate that one. You did some crazy stuff? Spasiba. Thanks, man. Yeah. Check it out. There's the service tower. This stuff was hard, man. It was difficult. It was difficult to play this way. Extremely difficult. Yep, there's the three orbiters and the 3 orbiters. Dude, I even crashed one of these things and I repaired it. I built the jigs in KSP for a Kerbal to be able to use EVA construction to repair the vehicle. So I never recovered it and we never brought it back to the hangar. That's the one that says Dart on it. Yeah, this thing actually crashed. It actually crash landed, and I used Kerbals and certain parts because most of Dart's parts can be replaced outside of the VAB. Kerbals can actually use EVA construction. So yeah, if you look, Dart was my test article. You can see it has docking ports on the wings for where it had jet engines attached to it, so where we could fly it around and test to see how good it was at landing. Guys, once again, what I like to tell people when I was doing this stuff is that I don't just play Kerbal Space Program. We engineer space programs. I build out the space program, the systems engineering. Doing this and trying to engineer out every single piece of equipment from the freaking truck that moves the stage all the way up to the pad, the towers, everything. You get a pretty good fundamental understanding of how space programs actually work. If you're newer to the stream and wonder how do I know so much about testing regimes and stuff, and how do I know what SpaceX is trying to do with their tests or anything. It's from doing this for years. Yeah. Yeah, the vanilla autopilot. That wasn't my idea, but yeah. Can we still use this save, or would you want to start fresh? That save is the SSTO save, Barry. I think starting fresh would probably be a good idea. Help me sharpen up again, you know? Yeah, everything. From hoist points on the vehicles to, you know, on-orbit usability. It got pretty nuts, dude. And then Dart crashed and killed a Kerbal, and I decided to do something different, and that was... We quickly learned that that's exactly what you don't do when something breaks. Yeah, I built that space station entirely from stages and equipment that were mounted on trucks when they left the SPH. How long until we stare at drawings and photos of Slick 6 during this project? Jensen Button is doing the Rolex 24. That's cool, Bandit. I'm going to be there. I got paddock passes, dude. I know people. Seriously. I'm going to be gone 3rd week in January, dude. Yeah. One does not simply pass up paddock passes. Can you get DOS's UHC mod list and do a run on that? Yeah, maybe. That was my problem. I never got entry, descent, and landing figured out right with Dart. Nowadays, though, you know what I would do with Dart? Give it a parachute. Have it get back to KSC and just parachute and land. That's it. He's in a Porsche. Awesome. I'm not sure. I forget which one. I have to go look. But yeah, see? Check that out. Yeah, right? Pretty cool, right? So these things are on landing gear. Landing gear are super freaking strong in KSP. So you retract the landing gear, it sets itself down and it doesn't move, right? But if you pick the landing gear up, I can take a truck, attach it, and we can tow the structure out of the way. Or a Kerbal can push it. In this particular case, a Kerbal, believe it or not, can push the entire structure out of the way. See? Pretty good, right? Yeah, Alex, in a little bit. Yep. The nostalgia, the voting in my heart, Freedom Rockets, Dart. The fact that the space program followed and mirrored real space history and the drama is so cool. It also stressed me out to the point where I gave up playing Kerbal for 6 months. So there's that. There's that. Yeah, there's the booster coming back. I'm not saying goodbye to Kerbal 1, Hibbit. At this point, I'm not even sure we're ever going to do that. Yeah, see. Recovery vehicles. This is a Dart that actually crashed. And I had a truck with a crane. And I have the Kerbals come here, attach a docking port, and then use the crane to actually pick up the broken parts of the vehicle, bring them back. I had a junk pile sitting outside of KSC. And then we started doing that. Then I decided to make Venture Star. And that proved to be very difficult. Yeah, I got you. Yeah. Dude, we should have just kept launching it like this. But whatever. Mistakes were made. Yeah. That was really, really difficult, dude. That was me at my, like, absolute best. Dude, you guys want to hear something crazy? This is for the long-time Kerbal players. Want to hear something nuts? I did this with no hybrid tech. This was all with just regular robotics. Can you believe that? We made all of this. The pads, the SSTOs, Dart, everything. No hybrid tech. Yeah, that thing was money, dude. That thing still works. LV5A still works. It's really good. I actually worked a lot of the kinks out of that design. No hybrid tech? Yeah, I built launch pads off of other launch pads. Look at that thing. Deployed small sats with it. Had a recovery helicopters, dude. We built out everything. I built everything. This is a picture of deployment. Check that thing out, dude. Fully 100% reusable. You just land it on the runway, tow it back to the pad, turn it upright, new payload, new fuel, send it again. Yeah, bananas. I sent it up to the space station too. There it is next to DART for some scale. Big Chungus flight, please. We got to go back to playing cities, dude. Hi, Vath. What's up, man? Yeah, I even built its own erector right there. Built out its own pad. Everything, dude. And the small one is actually pretty good. And then we built that thing. And that thing was the end of me for a little while. I scaled up its design. I took this thing, right, and built it with the smaller triangular panels to make its aeroshell and thermal protection system. And then I built a bigger version of it. I just scaled the entire thing up using the bigger panels. And that's a Mark III payload bay up there. This thing was a monster. It was an SSTO that could drop off 36 tons. 36 tons up, 36 tons down. No problem. And then I made a mistake in the design. I made a mistake that causes the thing to explode when it touches down. Still got the strong back? Yeah. Dude, the strong back to move this thing around was unbelievable. Yeah, that was a feat of Kerbal engineering. Look at that thing. The SSTO unloaded with no fuel in it was like 300 tons. I still will maintain to this day hybrid tech could fix this. Yeah, build my own launch pads, my own reusable launch pads. And I actually got it to work. I got it to work a couple of times. Yeah, the warping on the docking port. With hybrid tech though, dude, with hybrid tech, we could fix this. It could work. I don't want I don't want to. That thing was nuts, man. It had like 20 shuttle engines because we didn't have aero spikes. Dude, seeing that thing go plunge through re-entry was amazing, man. Yeah, that's the launch pad. Crazy, huh? See that? That's a truck. That's a Kerbal seat right there. That's the actual pad. It was a frame rate nightmare, dude. How would you have gotten around to making how would you have gotten about making a large expendable rocket instead? That was LV4. LV4 floating. Yeah. Was the hierarchy visualizer around when you built this? Actually, Theix worked on that during the SSTO program. Yeah, he got it done by the end of it. That was Theix that did that, right? Actually, that was after. Huh. Yeah, there it is. Dude, dude, we did this with no hybrid tech. You got to be kidding me. That's absurd. The real problem that I ran into with this thing is that fully fueled with payload, this thing is 2,400 tons. Kerbal just can't really understand how to deal with those load problems if you're not careful. So that was the end of that. See last. What's up, man? If you ever want to look it over. Oh, okay, cool. Where's your last? Honestly, I see KSP1 and KSP2 filling different niches. One will always be where the engineering and crazy creations with set physics and no fluff. KSP2 seems to be wanting to fill a different niche of a larger scope. Colony management and interstellar are the main things we will be doing. TLDR, I don't think SpaceX will follow the same treatment in comparison of CS2 and 1. I agree. It's very much apparent by the science mode missions that I'm not sure if engineering is going to be the focus in this game. But that's okay. That's all right. Still got KSP1, so I'm still going to play it. We could do stuff like this again. I actually wanted to give this another shot. Maybe not with SSTOs, but we could. Yeah, green. Yep. I never played. Don't want to get home from work and do the exact same thing in a game. Yeah, crew access arm for the SSTO. Reintegration hanger. Beast mode. That was awesome. Dude, with hybrid tech, this could all work. We'd have to really engineer out the hybrid tech better, but... Yep. That's the fueling sequence. You got to fuel from the pad. You got to refuel the pad. You got to bring out trucks to refuel it. Career mode missions. No career mode, please? Oh. We will. We will. Let's keep working with Vulcan and then we'll go from there. Oh dear. Yeah. The big SSTO just yeeted an entire lunar lander and like 4 or 5 satellites all at once. The thing was an absolute monster. Do you have to give weight provisions for life support in this? No, not without mods, Stellar. But with that being said, I always built stuff. I always had a design rule to not put like 3 Kerbals in a pod and send them to Mars in game in just a pod. Like you needed something that was appropriate. I always had like kind of proportions in my head for like what constitutes enough life support. But with that being said, there were mods for life support for Eclipse. Yeah, there were mods for it. You could do all kinds of stuff. The Kerbal 1 mods are amazing, dude. Modders are gonna keep that game alive for freaking decades, dude. Because yeah, and the crazy part is that there are mods for KSP 1 that make it look as good as KSP 2. Yep, deploying multiple pads there. That's when we brought it back. Payload reintegration. Oh, man. That thing was nuts. Absolutely insane. Dude, we actually got that damn thing working. Can you believe that? We got it working. We got the damn... The SSTO had no problems. It's the frigging pad that I couldn't get to work right. And that's when I switched back to Freedom Rockets, and then I was just like, that's... Alright, I've had enough. I was at the very tail end of Mission Mode 2. And then I said, let's work on other things. Like making helicopter carriers. And that's when I stopped, right there. Chopsticks. Oh, mission mode is what yeah, if we were to do it again, let's just do it without the career mode stuff. The SST program was on career mode. Like your career mode, not the games. Yeah, maybe. Yeah, and then I took a 6-month break from KSP, and yeah, we, that was the first thing I built when we came back. I built the K92, the auto gyro. And then I just started, yeah, then we started messing with Kraken drives. Yep. Little trip down memory lane there. All right. Back to cities.